So this video is meant to help us figure out how to write equations of lines given various different information. Now, as you can see on your screen, there's three different types of information that you will come across. You can either be given the slope and the y-intercept, you can be given the slope and a point, or you can be given 2 points. Now, every time you go to write an equation, you can use two different formulas if you like. What you want to do is try and pick the one that makes the most sense. So in our first example here, we actually are going to give you a picture of the graph, and then you're going to have to write the equation. So you can see that we have two given points, 3, 0 and 5, -4. And it's a good idea to notice that 3, 0 is your x-intercept, not your y-intercept. But it's a good point just to note and pay attention to. So if we use our point slope form, I am going to use, let's say, the point 3, 0. I'm going to leave the y there. My y1 is 0. My slope I don't know yet. X I will leave. My x1 is 3. Now, you can see that I have too many variables here. I have y, I have m, and I have x. So I need to try to figure out a value for m. I can either use the graph by starting at the point 5, -4 and asking myself, what do I do to get to 3, 0? I would start by going up 1, 2, 3, 4 spaces, and then going to the left 1, 2. What that means is my rise was 4, and my run, be careful, I went to the left there, was -2. So the slope of this line is -2. So now I will simplify this equation a little bit. Y minus 0 is y. M we can now replace with the number -2. And then in here, we will leave x minus 3. We'll distribute that -2. And we get the equation y equals -2x plus 6. Now, if we use the slope-intercept form to begin with, this graph doesn't show us the y-intercept, so I would still need to calculate my slope. This time, though, instead of using the graph, let me use my slope formula, which is y2 minus y1 over x2 minus x1. I'll still use those 2 points that I was given. So 5, -4, so -4 is y2 minus y1, which was 0, over 5, which is my second x, minus 3, which is my first x. And if I simplify a little bit, I get -4 over 2, which you know is -2. So now I'm at the point of y equals -2x plus b. So I have to figure out what b is. Let's give us a little bit more space here. So I know 2 points, 3, 0 and 5, -4 are points that work on this graph. So what I will do is replace x and y here with one of those points to try to calculate b. So let's see, y, we'll do 3, 0 was 0, x was 3, and we'll put in the other things that didn't change this time. 0 equals -6 plus b, so b equals +6, leading us to the exact same, now I'll put that right back in there, and that leaves us to the exact same conclusion that the first method did. You just have to decide for yourself which one you prefer. So next we have what happens if we're just given the slope and the y-intercept. In that case, it is definitely easier to use the slope-intercept form, y equals mx plus b. So we will plug in what we know, y equals -5x minus 1, and you are done. Okay, there is not much work when you are already given the slope and the y-intercept. Next, we come down to what if we're given the slope in 1 point, and I'll show you how to do it both ways here. So if we're going to use the point slope form, we would do y minus y1, which is -1 here, so be careful, I'm going to hold that in parentheses, equals my slope, which is a -3, times x minus my x1, which was 3. Okay, simplify a little bit. Y plus 1 equals -3 times x minus 3. Distribute that -3 on the right. And then I'll subtract this 1 off. And there's our answer. Now the other way to have done that was to use the slope-intercept form, where we'll fill in what we know, which is that y is -1 equals our slope of -3 times our x value of +3 plus b. -1 equals -9 plus b. Add 9 to both sides, so we know b is 8. And then we can plug that into our y equals mx plus b format, and now we have y equals, now remember, we knew our slope was -3. We didn't have to do any work to get that, x plus 8. And you'll notice how these two equations match. And finally, if we have 2 points, what do we do? Same idea, we have 2 different ways we can do this. So first, if I was going to do the point slope form, to find my slope, we could do y minus y1. So let's see, why don't I say, so when I do this, you could put in like a 2 in here so that you know that this is different. So we'll do y2 minus y1, so we'll do 9 minus 3 equals m, our slope, times x2 minus x1. Be careful of that negative there. So that means 6 equals m times 2 minus a -1 is really 2 plus 1, which is 3. So 3m equals 6, and if we divide both sides by 3, we know our slope then is 2. And then if we go back to our original equation, we would say now plug in a value for x1 and y1 only, leaving x and y alone like we had originally. So we will have y minus y1. Let's say I'm going to choose the first one, 3, equals our slope of 2, which we had just calculated from right there, times x minus, remember I used that first point, and now we have y minus 3 equals 2 times x minus a -1 is x plus 1. Careful, I should have another parenthesis there. I'm going to distribute the 2 and then add this 3 to both sides. Now if I wanted to do that using the slope-intercept form of y equals mx plus b, I'd calculate my slope first, which is y2 minus y1 over x2 minus x1. And hopefully now you're saying, oh, that's why you put the y2 and the x2 in before. It's the exact same idea. So we'll do 9 minus 3 over 2 minus a -1, and hopefully these numbers are looking familiar to you. We have 6 over 3, which is 2. And now if we plug that in for here, right there, and then we put in one of those points. Again, I'll use -1, 3 just to be consistent. So 3 equals 2 times -1 plus b. So 3 equals -2 plus b. Add 2 to both sides. And we rewrite our equation, putting in m and b. And you'll notice again we get the exact same answer, which is what should have happened.